belt drives. My name is Ian Street, and today's presenter is Heinz Waltzinger. And just as per normal, some housekeeping rules. There's going to be some opportunities for some questions. Everyone will be on mute, but there is some opportunities to write or to list some presentations down on the right-hand side of your screen there. And without any further ado, I'll just hand it over to Heinz.
Hello, good afternoon, and also very warm welcome from my side. My name is Heinz Watzinger. I am Global Product Line Manager for Gates TPU product. Gates TPU. Gates is very well known for rubber timing belt, rubber V-belt, and fluid power product, but it's not so well known for the polyurethane product, and so I'm happy that you take the time to listen to Gates TPU product and design considerations for belt drives. So we have started the webinars with two former sessions. TPU 101 was talking about the organization, what is TPU, belt types and belt product portfolio of Gates, and all the customization and additional product possibilities for TPU belt. The TPU 102 was about applications and target market segments, potential opportunities, and general applications. And today we see the TPU 103, which is going to more into the technical details, technical considerations, and the some engineering information, environmental conditions, and what data do we need to collect to suggest the right belt for the application. So when do we choose TPU versus a rubber belt? And our major application categories are different from the rubber belt. And as you can see here, we go more into the conveying applications, in the linear positioning, in vertical lifting, and then the rotary motion control and power transmission. That's applications that we share with the rubber belting, especially power transmission. So how do we dedicate and find out which product would be the better product for this application, rubber or TPU? And the first question we ask is that application a power transmission? If yes, most likely a Gates power transmission rubber belt is the better solution for you. If no, next question will be, is it a conveying application? If yes, most likely the TPU product can solve your application. If it's not a conveying application, then next question will be, is it a rotary motion control application? Rotary motion control, mostly it's a Gates PT rubber belt based on tensile strength and available belt dimensions. In TPU, we have more possibilities to be flexible in belt dimensions. If it's not a rotary motion control, then next question will be, is it a linear motion control application? Linear motion control, if it is a application for linear motion, and also here we have two possibilities, two product lines. It's the Gates rubber power transmission linear belt or the TPU belt. And it's depending on the application, on the environmental situation, and also tensile strength and effective tensile to check whether it's a PT or a rubber belt or a TPU belt. And if it's not a linear motion control, then the other application will be lifting. And on lifting, also here we have two options, Gates rubber PT belt or a TPU belting. In very often in lifting applications, people use, or flat belt is a good product, and with flat belt, the TPU is the only option. Comparing the Gates power transmission product versus the TPU product, we have chosen the Gates Polychain, Gates Power Grip GT, and the TPU products. And we have chosen also various attributes where we can benchmark or compare and find out what would be the best product for your application to solve. And on the torque, as you can see, of course, Polychain is the highest torque capability product worldwide in the industry, and Power Grip GT and TPU are pretty par on the torque, but on a lower level. The speed with standard sprockets is pretty similar, 30 to 33 meters per second. That's across all the three products. A noise level here we have, we know that Polychain, because of the hardness of the teeth, Polychain is gets pretty loud at higher speeds, and Power Grip GT and TPU would be less noisy. The dimensioning of these three products, the endless length is pretty similar. The 20 meters for Polychain EL, extended length. Power Grip GT, of course, is limited because of the limited mold size of 6.8 millimeters. And the TPU with the truly endless flex belt, we go up to 24 meters as truly endless belt. As long length belt, we have, of course, longer opportunities. Polychain EL extended length up to 274 meters. But with limited width. The Power Grip GT as well, 180 meters, and the TPU product is pretty much almost unlimited. 300 meters is a number, but that's also depending on pitch and width of the belt, because when it comes to very big belt, heavy belt, we have some limits in the material handling in our production locations. Other attributes like conductivity, all three products are electrically conductive or antistatic. In the TPU product, we need to use a special polyurethane resin to get the polyurethane antistatic. So our standard product that we use in TPU is not conductive. So if you need an antistatic belt, please just specify that and we will offer you the right product. Temperature range, here the Polychain is definitely something which is superior to all of the other products, going from minus 54 degrees to plus 85 degrees C. Power Grip GT, similar but slightly reduced, and the TPU product is a little limited here. The complete range goes from minus 30 to plus 70 degrees C. However, the standard polyurethane resin is limited by minus 5 degrees C to plus 70. And if you need to go lower than minus 5, then we will also have to use a special polyurethane resin, which is the low temperature resin, and then it goes down to minus 30 degrees C. Also here, if you need temperature range below the standard range, please specify, and then we will offer you the right product for it. Chemical resistance, as you can see here, the Polychain and the TPU has excellent chemical resistance against most of the chemicals and liquids that are used in the environment of drives. Power Grip GT, limited. And food applications, here the TPU belt is really the only one that is fully compliant with the FDA, USDA, and the EU food regulations. Also here, if you have an application with direct food contact, please specify that in your inquiry. We have to use special TPU resins also to be compliant with the specific regulations. Customization, also here, Polychain and Power Grip only offer little opportunity to customize belt. On the TPU belt, since we use a thermoplastic material, that we can re-weld and machine and apply backings and profiles and so on and so forth. We have quite a good opportunity to customize our belt to develop special solutions for your specific application. And then it comes to the dual-sided power transfer. There is no possibility with Polychain, but Power Grip GT and the TPU Superflex belt have the opportunity to use double-sided belt as well. So what options do we have on the TPU belt? First of all, and this is a quite often asked question, do we need a welded belt or an endless welded belt or a truly endless belt? As said, with the thermoplastic polyurethane belt, we have the opportunity to weld and remelt the polyurethane, and that's why we can create endless welded belt. Of course, endless welded belt have limited power transmission or limited tensile strength, since the cord are not welded at the welding sections, and so the polyurethane has to take the entire load. So we have to respect limited tensile strength on the welded belt. But in most conveying applications, and as we've seen in the applications, that's one of our major fields. It does not really, the tensile strength is not so important on this application. Mostly the width of the belt is determined by the size of the product that we need to transport. Therefore, in most cases, a welded belt will work well for conveying applications. For rotary motion or light power transmission, we generally recommend truly endless belt. And also here we have some product opportunities with the TPU belting. Nylon. As you can see here on the picture, the belt construction starts out with the tension member. We extrude polyurethane around the abrasion resistance of the product. However, in some, especially in conveying application or in higher speed application.
Heinz, we've got you coming in and out with audio. We still can't currently hear you. Are you there? Heinz, you might need to reconnect your audio connection if you haven't already.
Hello, Priscilla, can you hear me again?
I can hear you now.
Oh, okay, sorry, I had to, something is wrong with my internet connection, so I had to switch to landline. Okay,
Perfect.
we'll restart to share my screens here. And if you could just give me a hint where I stopped, or where you stopped hearing me.
Yeah, literally when I interrupted pretty much. So I think it was the beginning of that slide.
Okay, very good. Then I'll continue with that. So the basic belt runs on the tension member, and we extrude polyurethane around it. Usually, polyurethane is highly abrasion resistant, and so we don't need any fabric to improve friction and to improve the abrasion resistance. But on high-speed applications and also on conveying applications where the belt slides over a slider belt bed with some weight on the back of the belt, we intend to reduce friction. And on high-speed applications, the nylon fabric helps to reduce the noise. And so therefore, we can apply nylon fabric on the tooth side and for some special applications also on the back side. On the TPU, we have various opportunities, various options. Our standard TPU is 92 Shore, very good abrasion resistance, and that's what we use in, let's say, 85% of all applications. Then for food applications, especially with direct food contact, we use a special polyurethane resin, which is 85 Shore A. For the cold temperature, we have a special low temperature resin going down to -30 degrees. And then for antistatic belt, we use a conductive polyurethane resin that applies or is in the range of the Apex applications, conductive product. So talking about cord, our standard cord is steel cord. Steel cord is the highest tensile strength and most flexible cord, and therefore in most applications it's used. Steel has less stretch and has the best flex life. For wet environments, we have the option to use stainless steel. We have to respect that stainless steel shows lower strength and lower flex life than carbon steel, so we have to respect reduced technical values. And also, since stainless steel is a quite expensive product, we only produce limited pitches, pitch range with the stainless steel cord. If you have applications in wet environment or corrosive environment, also our WR product line would be an option for that instead of using stainless steel. WR means water resistant belt, and here we completely encapsulate the cord so that it's not exposed to the environment, and therefore the corrosion is not an issue. For some applications, however, aramid is a better product, and especially if the metallic steel cord influences some sensoring or some non-metallic applications. That's one point, and the other application would be especially when we talk about vacuum belt, where we have to punch holes into the belt. It's nicer and easier to use aramid coated belt because the punch holes in steel coated belt is a nightmare, and it's not as easy as to use aramid cord for vacuum applications.
For the steel cord, we have multiple opportunities to use different constructions. And we have a typical example here with the 8010 belt. So the 8010 belt, we have various options of steel cord within the same dimensions and geometry of the basic belt. So our standard steel cord has a design of what we call 7 by 3 by 0.15. And that means the cord is composed out of 7 single strands, 1, 2, 3, 4, 5, 6, 7. And each strand is composed out of 3 wires. So that's how it's designed 7 by 3. And each single wire has a diameter of 0.15 millimeters. This is a standard cord for 8010 belt or for HDD 8M belt. If we need to use smaller pulleys, which is smaller than the recommended pulley diameter for a standard cord, we can use a special high flex cord. And as you can see here, the size, the outside diameter of the cord of high flex is completely the same like the standard cord. But as you can see easily on the picture, we use a lot higher number of single wires. So the construction of this cord is we have one center strand which is composed out of 3 single wires, and then we have 5 outer strands which are composed out of 7 single wires. So a lot more complicated than the standard steel cord. Each single wire is smaller, 0.12 millimeters instead of 0.15 millimeters. And because of that thinner single wire, this cord is more flexible, can go around smaller pulleys versus the other one. And the third option then is a reinforced cord, which means bigger cord and higher tensile strength. And this design you can see here, pretty much the same design as the 8010 high flex cord, but the single wires are bigger. It goes up to 0.15 millimeters. The diameter of the standard cord and the high flex cord is 0.9 millimeters, whereas the reinforced cord is bigger, it's 1.2 millimeter. So that shows you the various options we have by using standard cord, high flex cord, or reinforced cord for the higher belt tension. So pretension, belt pretension, another very important feature or thing that we need to respect when we go into an application. The belt pretension is the most important thing that we need to respect when it comes to a proper belt operation. Most of the belt failures we see are caused by incorrect pretension of the belt. What does the pretension do? The belt pretension prevents the slack side from sagging, and it ensures a proper tooth meshing. And with the proper tooth meshing, we have a good belt life. So we can see 2 typical examples here. It's a linear actuator, and the linear actuator needs to move a certain mass or weight from A to B. And we have 2 applications here. On the one side, we have the driver pulley on the right side, which is we call a head-driven application. And that means when the weight starts from here and the driver applies the tension or the torque, then we have a tight side length of the belt, which is elongating. And all this elastic elongation needs to be assumed by the slack side. And as you can see here, the ratio between the tight side length and the slack side length is in the range of half and half, plus or minus. So the pretension here can be limited because the slack side length is good enough to assume the elastic elongation of the tight side length. The more difficult application is when we have a so-called back-driven application, and the driver here would be on the left side, and the same weight has to be moved from left to the right side. And here, if you can imagine, we have a very long tight side and a very short slack side. And all this long elongation, elastic elongation of the tight side have to be assumed from the short length of the slack side. And therefore, the pretension here on this application needs to be much higher versus the first application. Of course, in reverse applications, like a typical linear application, we change the directions, and so we have, in some cases, a head-driven, and the reverse direction will be a back-driven actuator. So the pretension is pretty much determined by the ratio between the tight side length and the total length of the belt. And again, this is a very important feature and very important fact that we need to respect when we calculate and install a belt drive. So now going to applications. What do we need to consider with our typical TPU belt applications? And as said, one of our major applications is conveying. And these three pictures show you that conveying is it's a very wide field. You cannot imagine, and that's what the TPU belt is very interesting for. You always can see new applications every single day. So mostly it's start-stop applications, synchronized conveying, and also some process type of transportation. So on the conveying, what we do, we move weight and products from A to B, usually. And the forces on the belt is the mass or the weight of the product. Some of the conveyors are inclined, so we have to respect the inclined angle. And then also, of course, the acceleration rate or the top belt linear speed and the acceleration time. And some frictional forces. Of course, the mass that is sitting on the back of the belt is a weight, and the belt is sliding over a slider bed, and we have to respect the friction force that appears between the belt and the slider bed. And of course, then the other what we have to respect is also the so-called design envelope, so minimum pulley diameters, maximum belt width that is applicable in your application, and all that also influences the belt that we can choose from our portfolio. And then, of course, also environmental condition, temperature, humidity, chemical interactions, abrasives, etc. Belts, typical belts for conveying are trapezoidal belt, usually endless welded. And as you can imagine, when a belt slides over a slider bed, a round top or round tooth belt would be not ideal for that. Since the round tooth slides over the slider bed, we usually prefer a belt with a flat tooth. Whether it's a T-pitch or an AT-pitch, that would be ideal product for conveying application. We talked about minimum pulley diameter, and especially on conveying applications, we often see belts with backings on it. Backings for different to provide different features. to the belt. Mostly it's high friction backings to convey different materials. Sometimes it's low friction packings or cushioning backings for belt damping. And the harder the backing material is and the thicker the backing material is, we have to increase the minimum pulley diameter to avoid the backing to crack and to delaminate from the belt. And here we have a typical example. It's a standard belt, a T10 belt with a Linatex or rubber backing on top of it for conveying application with high friction. And we have some indicator for the minimum pulley diameter in our catalog. So you can see in our backing part of the catalog that we have natural rubber backing material, and we have a minimum diameter factor of 20. That means the minimum diameter factor of 20 has to be multiplied by the thickness of the backing. And so we have for example, a 3 millimeter Linatex backing times 20 as the minimum diameter factor results in a minimum pulley diameter of 60 millimeters. If we would have just the standard belt T10 pitch without any backing, the minimum pulley diameter would be 44.56 millimeters. So by adding 3 millimeter Linatex backing, we need to increase the minimum pulley diameter from 44 up to 60 millimeters. Same with profiles. If we have applications where we apply profiles and weld profiles onto our basic belt, we should be trying to weld the profile only located over a tooth. As you can imagine, the belt, when it bends around the pulley, it will not bend directly on the tooth, but it will bend in the gap between the teeth. If we weld a profile on over the gap between teeth, we will avoid and we will increase the stiffness of this belt to go over a pulley, and therefore we need to increase the pulley diameter. We have also indicators here in our catalog, and here is an example, an AT10 belt with a foot thickness of like 5 millimeters. This is the foot thickness or the foot length. And that requires 18 teeth when the profile is located over a tooth. When we weld the same profile over the gap between the teeth, we need to increase the pulley diameter or the number of pulley teeth from 18 to 30 with the same foot length. So that shows you how important it is to respect the right position of a profile on the belt. Of course, if the application requires that the profile is not over the tooth, then we just have to respect the pulley diameter. Next application, linear positioning. Typical application you can see here, linear actuators driven by belt or complete Cartesic robot systems. And here we have two applications. It's a two-pulley drive or the omega drive. The two-pulley drive, we have already talked a little bit about the design considerations for these two-pulley drives. On omega drive, the basic consideration is absolutely the same. We have to make sure that the slack side is always under a minimum tension. Open linear belts are mostly used in linear positioning since the belt does not go around the pulley. And in the two-pulley drives, and the belt ends are fixed on the construction or on the on the floor on an Omega drive. And mostly we use high capacity pitches since the linear positioning require mostly high acceleration rates and high positioning accuracy in the application. Therefore, AT pitches or HDD pitches are the most common pitches in this application. And in most cases, even with reinforced steel cord, ATL type of product or HDDL type of product. And also here we have the so-called HPL products, which is higher strength steel cord and Gates GT profiles. Design the forces on the belt for linear accuracy, linear action is of course again the mass or the weight to be being positioned, the inclined angle, if it's a horizontal or vertical drive, for example, the acceleration rate or the maximum speed and the acceleration time. And then some of the applications experience external forces, for example, like machine tools, or when somebody pushes onto the belt to that mass. That has to be respected. Then we also have, in some applications, to consider the pulley material because when it comes to big pulleys or extremely high acceleration rates, the inertia of the pulley is a factor. And in standard applications with small pulleys and aluminum pulley material, that's usually not that big of a factor, but when it comes to big pulleys and steel material, then it's worth to respect the inertia here. And then, of course, also we have some frictional forces, mostly with linear bearings. That is also minimal, but at least it's worth to double check. Also here, it's a slight difference between a two-pulley drive or an Omega drive, and we have to respect the design envelope, desired pulley diameters, maximum belt width, and positional accuracy, and of course also the environmental conditions. So vertical lift, some applications you can see in automotive plants, in scissor tables where your hydraulics is not applicable, or in intralogistics warehouse, automatic warehouse systems. We have two applications in vertical lift. It's the open-end system with weight and counterweight, or the closed-loop system. Closed-loop system is pretty much similar like a linear actuator, a vertical linear actuator. And the typical belt that we use here is flat belt, especially with open-ended systems. And here we have a very wide range of BFL 20 to BFL 48 for really high tensile strength application. And for some of the closed loop systems, we use reinforced high performance pitches like the ATL or the HDDL or the HPL products. Design consideration, of course, the same thing, mass or weight for being lifted, and of course also the counterweight and the acceleration rate. And the two different applications, open-end or closed-loop systems. And of course also the design envelope, pulley diameters, and maximum belt width. On these applications, especially when it comes to very heavy loads, we have to respect that because of the elastic elongation of the steel cord, we may have to use specially designed pulleys so that we respect the elastic elongation around the circumference of the pulley. And if you have these applications, please consult our application engineers. They will help you to design and to calculate the right belt and pulley system. And then we come to the motion control applications and power transmission. We have clustered that into one presentation and one slides because the design considerations are very similar. We have rotary motion, and we have mostly two pulley drives with some tensioning idlers on it. And here the design consideration is maximum torque or power, rotational speeds, and the design envelope, pulley diameter, center distance, belt width, etc. And here with these applications, we usually use truly endless belt. There could be the Synchro Power sleeves or the Gates Superflex belt. And then another application will be this foot belting. Foot belting, as you can see here, also we have two typical applications, which is the C drive. As you can see here, a type of a C shape of this conveyor for inclined conveying, or the standard two-pulley drive. And the pictures you can see here as well, mostly the straight conveyors, whether are completely horizontal or do have some limited inclined angle as well. For the foot belting, the design considerations are slightly different, but again, we are talking about load, maximum conveyor capacity or maximum load conveyed. Here we have a little slightly different. We have kilograms per minute and also the speed per minute, meters per minute. Inclined angle, of course, is also interesting. And then since these belts are usually traveling over a slider bed, we have also to respect the friction. Depending on the slider bed material, the polyethylene slider material, stainless steel, or any other slider bed material. And usually we also apply cleats or profile or corrugated sidewalls to this belt. And on corrugated sidewalls, you have to also respect that the minimum diameter is going to change and determined by the height of the sidewall. Design envelope is always a criterion here, pulley diameter and the dimensions, belt width, mostly determined by the product to be conveyed. The belt splicing in foot belting, foot conveyor belt is also important because most of these foot conveyor belts are designed such that the belt has to be cleaned on a regular basis, and in a lot of cases, the belt has to be removed from the conveyor, has to be cleaned off-site, and has to be reassembled to the conveyor. And therefore, for these applications, you use mechanical splice. The post-gate post-relays splice would be the best solution for that because it's very easy to disassemble and to reassemble a belt in the conveyor. We have 4 foot conveying belt types. The most common one, the most common one is the PC20. It's a 2-inch pitch belt. It's synchronous conveying. A PC10 with 1-inch belt, and the CC40, which has the tooth only on the center of the belt width, especially fit for draft foot conveying, and also, of course, the flat belt FC12 or FC9. For foot belting, we have a special application form that's a little more detailed, and when you have an application where you need to determine and calculate and suggest a product, a foot belt, then you can reach out to our application engineers to get access to this application form. So on the belt basics, what do we need to collect? Which information do we need to collect to determine the right belt for you? First of all, since most of our belt are type of custom belt, customized belt, the made-to-order belt, it's important for us to have an idea about quantity of the belt drives. In some of this, or in a lot of applications, the customization is also, of course, the cost of the customization is determined by the quantity of belt that we need to customize. And in a lot of cases, we produce just 1, 2, 3, 5 belt, and certainly the fabrication process is different if we just make 1 belt or if we make 10 belt or 100 belts. And the fabrication process determines the cost of the fabrication work. So quantity of belt drives is important. And then, of course, especially when you have an existing drive, we need to know the pitch and tooth profiles, the dimensions. If it's an open-ended or an endless welded or truly endless belt, we need to know the core type, if it's aramid steel or stainless steel, if you need nylon fabric or if you have any other fabrication on it, backing profiles, and so on and so forth. So that completes my presentation, my information of TPU belt drives. Just as a reminder, Gates is not rubber anymore. It's TPU, thermoplastic polyurethane belting. And I would be happy to see more of your applications. And now I'm opening the session for your questions and we'll try to answer it.
Heinz, we've got one question come through that's, are the belts available in preferred colors?
Yes, that's a possibility. Our standard color is white, except the flat belting. The flat belting is black in color, but we also have black color available, so you can use the black color. The sleeve product is in dark blue, and if you need a special color, special application, we can add color pigment to our polyurethane resin. It's just a question of minimum order quantity. Usually to add color pigment is a little demanding because we have to clean our extruder, and that takes some time, and that's not good, or that's pretty costly, and therefore we recommend to use special colors only if we have a minimum order quantity.
We've had another question. Are the belts static free?
Yeah, I guess this is referring to anti-static belt or conductive belt. Our standard product is not anti-static, but we have anti-static versions available, so we can we have a special TPU resin available, so we can extrude the belt with conductive polyurethane resin. That's called the R4 resin. And also we have a special nylon fabric, which is anti-static, and we also can apply anti-static nylon fabric to belts for specific ATEX applications.
Now, we've also had a question that who is our application engineer in Australia? So I suppose I'll take that. The first point of call is Ian. And then Ian obviously can liaise with our, so Ian Street, who's based in New South Wales, but he can liaise with the overseas design teams, including Heinz, and the engineer teams on any requirements. But yeah, Ian's your best local contact. Are there any other questions? I don't think there's any more that have come through. Not that I can see, so I think we've covered them all off. But I want to thank Heinz again for presenting today's webinar and also the other 2 webinars previously. I know there's a lot of people that have got quite a lot out of them, and all of the webinars have also been recorded. So if you've got other people within your organization that would get value from them, you just need to go to the registration link, and all the past recordings are available there as well. We will also be sending this recording out at the end of this program as well. Well, good. Well, thank you again, Heinz. No other questions have come through. We appreciate your time, and thank you everyone for joining.
Thank you, everybody, for joining and taking the time. And Priscilla, it has been an absolute, I very much appreciate, and it has been a pleasure to get the chance to present the TPU product range to you.
No problem. I'm sure we'll get you involved in some more programs in the future.
I hope so. Look forward to that.
Beautiful. Thank you all.